All right, welcome back. And today we have a question called swap every two nodes in a linked list. So the question is as follows. Given a linked list, swap the position of the first and second node, and then swap the position of the third and fourth, etc. So every two nodes, we're going to swap them. So here is some boilerplate code, and yeah, this is what the node looks like. We get a value and a next address. So let's go to the drawing and then see how we could do this. So I have an example here, 1, 2, 3, 4, 5. So technically, given the example, what you're supposed to get in this after 1, 2, 3, 4, 5, you're supposed to end up getting like maybe 2, 1, and then 4, 3, and then 5 is okay because it doesn't swap with anyone. That is actually what you need to get. So how are we going to get these numbers? When you think about it, swapping is, it seems quite difficult because first of all, 2 is going to be first. You're going to have to get this guy to point to this guy. And then for 1, you're going to have to point this guy to the next guy. 3, but then it wouldn't be 3 anymore because you're going to be swapping 3 and 4. So that means you're going to have to go all the way to here, right? And then also the head will be now on 2 instead of 1. And then 3, instead of pointing to 4, it's going to point to 5. And then 5 is going to stay here, which is fine. But then 4, instead of pointing to 5, it's going to point to 3. As you can see, this method might be a little bit quite complicated. So the trick here is less about a technical trick, but more about if you can learn about the constraints, or if you can read the question right and then ask the right question. So you can kind of ask the question, can we just modify the value inside the node? And in here, it doesn't necessarily tell you, it doesn't say that you have to move the nodes. You can actually just swap the values if you want. So let's just swap the values. Swapping the value becomes way easier because what you can do is literally just do the same thing for every two movements. So imagine you have a pointer here. This is your current pointer. And then what you want to do is you want to swap these two numbers. So how do you get this value? This value is quite easy to get because technically this is just current dot next dot value. And then you're going to get this guy. And then here you get current dot value. So the key thing to do here is to just swap them. So it's as simple as saying current dot value, and then we also want to swap the current dot next dot value equal to, and then we just swap these two. So we're going to bring this guy here and then this guy here, right? Okay, so we get current dot next dot value. Oh, I don't have space anymore, but current dot value. So that's how we swap both of them. So here, as you can see, if we just do this operation right here, then what we're going to get is we're going to get 1 instead, and then 2. Awesome. And then next, when we're going to go to the next one, we're just going to go through the linked list by 2. So our new current becomes this guy. So then this guy would be the next value. All right. And then we do the same thing. This becomes current dot next. And then the values, we swap them. We're going to get 4, 3. We're going to stop when we see that there's no 2 nodes in front of us. If there's no 2 nodes in front of us, we stop. So that's it. You actually just swap the values instead of doing all this node acrobatics right here, which is way too complicated. So what you can do is you literally just look at your current node and then swap with the next node in terms of value, and then you're going to jump by 2 in your linked list. So what is the time complexity of this? Well, we go through the array once, so that means that's O of n. And then the space complexity, we didn't add any new nodes or any new arrays or anything, so that means it's O of 1. The space complexity is constant. All right, cool. So that's pretty much it. So let's code this up. All right, so now let's look at the code. So first, what we want to do is we want to have a variable head, which is the head of the list. This is actually not very necessary. It's mostly for aesthetic purposes so that we can understand what we're doing. So this points to the head. And then we want to initialize our current pointer to the head. And then now what we're going to do is we are going to iterate through the list. And what do we want? We want to make sure that the current node is not none, and also the next node is not none, right? That's why we want to make sure we can swap. And when we swap, we need two nodes. So that's why it's a current and a current next. So what do we do now? Now we swap. So how do we swap? We just do the same thing as we did when we wrote on that drawing. Then current next dot value equals, and then we swap the value, current dot next dot value, and then current dot value. All right. And then what we're gonna do is we want to skip. We want to skip twice. So current dot next dot next. That way, instead of just going one node ahead, we're going two nodes ahead. All right. And then we're gonna return head. So let's run this. All right, this works perfectly. And then, yeah, we could change it up a little bit. Let's see if it's 2, 1 instead, 4, 3, and then 5. Then it should give us 1, 2, 3, 4, 5. All right, perfect. That works very well. We could try some other examples too. Let's see, maybe 1, 1, and then 2, 2, 3. This should not change anything. It should only give us 1, 1, 2, 2, 3. All right, excellent. All right, let's print both of them. And then, yeah, so that's pretty much it. I hope this was interesting. And yeah, thank you so much for watching, and see you in the next one.